Hello everyone, my name is Rihan and I'm an assistant professor in TU Delft. Today I'm going to share with you Amalur next generation data integration in data lakes. Today we are going to talk about something old and something new. Let's begin with the old topic, data integration. Data integration is the process of combining heterogeneous sources and provide one unified access for the users. Usually, we need to conduct schema alignment that includes several steps. To begin with schema matching, we will need to find the correspondences between different source schemas. Then we can merge the source schemas and create one mediated schema. Of course, a user can also directly design a schema. And then with schema mapping, we can formalize the semantic relationships between different sources and the mediated schema. Data integration process usually ends with query reformulation. That is to transform the user query from the mediated schema to the source schemas. Now, when we start talk about data integration in a data lake, we also need to consider data discovery. That is to find the related data sets from a large amount of sources in a data lake. Now let's talk about something new. Our Amalur system, which is trying to support linear algebra-oriented data integration in a data lake. That is, what we have from the user are not queries. Instead, they are machine learning models, which are part of the data analytics tasks. So our goal is to decompose and rewrite the machine learning models such that they can be executed in each separated source. In our system, there are two main components. So first, we know that from a data integration system, we can get the row matching information from record linkage. We can also get the column matching information from schema matching and mapping. Then with the first component, we transform such information into the form of matrix. Then in the second component, the process is quite similar with query formulation, but here we try to transform linear algebra operators instead of queries, and we transform them from the target table into each source tables. And then in the end, we combine the results of the execution from each source tables. Of course, to build such a complicated system, it is not sufficient just with two main components. There are still many open questions. To begin with, it is already known that factorization not always helps to improve performance significantly. That's why it is important for us to know when shall we do the factorization. Another thing with linear algebra rewriting in a data lake is that different from traditional data integration system. In a data lake, the relatedness between the sources is fuzzy. That's why it's also interesting for us to integrate such fuzziness into the matrix generation and the rewriting. The third direction is that already known data integration has many well-established formal results. We are also very interested in building the new theoretical foundation to support linear algebra processing in a data lake system. Finally, we also hope to support large-scale machine learning applications. Now, if you get a little bit interested with our Amalur project, please follow us on GitHub and Twitter. That would be all for my talk today. Thank you very much.